Hello and welcome. Today working with types of relation. And if we are going to types of relation, one of the most important is to understand relation. So you can watch the previous video before starting this. Previously, the relation is the set of ordered pairs that satisfy the relationships, and the relation between two non-empty sets is the set of ordered pairs, which is the subset of Cartesian product of two sets A and B, is read as A cross B, and the relation from set A to B is denoted by this symbol. Now this is the relation previously of two non-empty sets and Cartesian product. In this relation, the B is the multiple of A, in which 4 is multiple of 2. B, this is B, B is multiple of 2, that is 6 is multiple of 2. B is multiple of A means 6 is multiple of 3. Now come in the important topic. To identify the types of relation, the set is required and the Cartesian product between same set itself is also required. To find the Cartesian product, first element taken from left and second element taken from top. Now for the element 2, 2 comma 2 is the one ordered pair, 2 comma 3, 2 comma 4, and for the ordered pair, for the element 3, 3 comma 2, 3 comma 3, and 3 comma 4. Now taking the element 4 as a first, then 4 comma 2, 4 comma 3, and 4 comma 4. If we arrange in the arrow diagram, left on A set and right on also A set, 2 paired with these 3 elements, 3 pair with these 3 elements, and 4 pair with these 3 elements. And A cross A is set of all possible ordered pairs by using arrow diagram or by using this table: 2 comma 2, 2 comma 3, 2 comma 4, 3 comma 2, 3 comma 3, 3 comma 4, 4 comma 2, 4 comma 3, and 4 comma 4. This is also a set, single set, which is the set of all possible ordered pairs. Now there are 4 types of the relations, which are reflective, symmetric, transitive, and equivalence. Now in the reflective relation, for all the elements in set A, there are the element 2, 3, and 4. For every element is related to itself. That type of relation is called reflective. Now let's focus on the example. For the element 2, 3, and 4, like first element 2, 2 is mapped itself, 2 is related to itself. For the second element 3, 3 is also related to itself, and 4 is also related to itself. So this is the reflective relation. All right. Now secondly, now in the symmetric relation, for element AB belong to A means taking element A and B from the set A, and A is related to B in the relation R, then it gives that B is also related to A. That type of set is called symmetric relation. Now previously here in the reflective relation there is a word for all, and in the symmetric here is only for. For all means there should be the every element. For means only taking the few element. Like if we take only 2 and 3 element are from the set A, there is a ordered pair 2 comma 3, A comma B, and it gives us 3 comma 2 also. All right, this is the symmetric relation. And similarly we can take the another pair of the element A comma B from set A. These are 2 and 4. For the element 2 and 4 there is a ordered pair 2 comma 4. Now it gives us, it implies that 4 comma 2 also the ordered pair in the relation. And similarly we can take 3 and 4. For the element 3 and 4 there is a ordered pair 3 comma 4. Now it gives us, if we interchange first and second component of 3 comma 4 element, we get 4 comma 3. This is the symmetric relation. Now what is the transitive relation? This is one level high. All right, now for the element A, B and C in set A, now only taking the some elements, not compulsory to take all the elements. All right, now taking the element A, B and C from set A, if A is related to B and B is related to C in the relation R, it means that there are the two ordered pairs in relation R, A comma B and B comma A. All right, now it gives us A is related to C. First is related to last. Now, in these two ordered pairs, in the ordered pair A comma B, the second component is B, and in the ordered pair B comma C, the first component is B. If these two are equal, then A is related to C. It means the transitive relation. Now, in the example, in the Cartesian product, 2 is related to 3 and 3 is related to 4. It gives us 2 is related to 4. Now this is the example of the transitive relation. 2 is related to 3 and 3 is related to 4. It gives us 2 is related to 4. This is the example of transitive relation. Then what is equivalence relation? The equivalence relation is all three relations, reflective, symmetric and transitive, in which relation these three relations hold, satisfy all these three relations. That type of relation is called the equivalence relation. Now as an example, now is there a reflective or not? Now let's check that. The reflective means every element in set A is related to itself. It means that 2 comma 2, 3 comma 3 and 4 comma 4. Now it is the reflective. Now to check the symmetric or not, symmetric means A comma B gives the B comma A. Suppose 2 comma 3 gives the 3 comma 2. If we interchange the ordered pair, if we interchange the component of these two ordered pairs, all right, it holds the relation. 2 comma 3, if we interchange the component 3 comma 2 also in this relation, so it is the symmetric also. Now to check the transitive, is it a transitive or not? Now for the transitive, previously we have already talked here, like A is related to B, 2 is related to 3 and B is related to C, it is 3 is related to 2. It means that it gives A is related to C means first is related to final last, that is 2 comma 2 is there. Yes, 2 comma 2 also here, so it is the transitive also. Now finally we can denote the reflective, symmetric and transitive like this. For every element in set A is related to A means every element is related to itself. Now in the symmetric, if A is related to B, if there is an ordered pair A comma B, then it gives us B comma A. B is related to A. Now in the transitive, if A is related to B and B is related to C means if there is an ordered pair A comma B and B comma C, then it gives us or it implies that A is related to C. That is the transitive relation. And finally, equivalence means reflective, symmetric and transitive. In the next video, we will talk about the function.